Hi, folks. I wanted to talk for a minute about um, network selection. When you're dealing with, um, sorry, when you're dealing with figuring out which networks to declare for your routing process um, on any given network, any given device in the topology, you need to think about a couple of things. Um, are the networks that I'm declaring on this device? Or am I accidentally trying to declare all networks in all locations? I've actually seen students make both of these mistakes. Um, Sometimes a student will just look at all the networks in the topology and declare every network everywhere. While that technically does what you need to do, it is not a good idea because you're declaring too much. The other mistake that I see students make is that they declare the same set of networks on every device in the topology. So it sort of works on the first device. It works on the first device. It sort of works on the second device because they're talking to each other. And then the further away you get from that, the less effective that approach becomes. Now, the example I'm going to use is a lab from chapter 9 of the Cisco Scaling Networks course. But this applies to any routing protocol. Um, pardon me. RIP, EIGRP, OSPF, BGP, the whole nine yards. Um, so what I'm essentially going to teach you is how to look at your addressing table, and once you've done the interface configuration correctly in the device, how to look at the routing table before you start routing and figure out which of these networks belong, which of these networks, which of these routing table entries need um, network statements of their own. So let's get started. Okay, so here I am. Um, so what I'm going to do is use the 9228 lab from Scaling Networks. But if you're taking another course that needs routing info that involves routing, the principles still apply. So what I've got here, I've got the instructions, I've got the topology, I've got my initial configurations when I did this in the physical lab um, some time ago. So let's look at what we're really learning under the hood, beyond the mechanics of simply implementing a routing protocol of any kind, is understanding the kinds of directions you'll get. Um, if they just hand you a topology diagram and a subnetting table, and they say, make it happen, you need to be able to jump from those two, that set of requirements, that set of specifications, and run all the way through to a fully functional, fully converged network. So we need to think about what areas are we in. And if you're thinking about the addresses that are on the device and the areas that the device are in, now when I talk about areas, of course I'm talking about OSPF. We're not, but still the broader concept remains. If you're thinking about the routing process you should be using, the autonomous system that you should be in, say for example for BGP or EIGRP, because they use AS numbers. RIP and OSPF use process IDs, and OSPF also uses an area number. So if you're thinking about, if you keep the mental model of the network in your head, and if the network is much too large on the whole for you to keep the whole model, the whole topology in your head, just divide and conquer. Think about the device you're configuring and the devices that are adjacent to it. What areas are they in? And am I actually doing what I know I should be doing? And if what you seem to be doing and what you should be doing are diverging, take that as an indication that you need to rethink what you're about to do. Say, for example, um, let's go to router one. So we've got router one, which is, as we notice, it is in area one. It is in area 0, and it has a link to the cloud. So that makes it a backbone router, a regular area router, an ABR, an area border router, and an ASBR. So it's got 4 separate roles simultaneously. Compare that to router 3. Router 3 is an internal regular area router because all of its interfaces are in router 3, or in area 3. And so if all the interfaces should be in the same area, it's internal. If the area that it's in is something other than the backbone, then it is obviously a regular router. So think about the roles of these routers. Think about what networks they're a part of. Think about this honestly any way you need to. Whatever works for you, do that. But make sure you're asking yourself, what I am about to do congruent with the requirements, the specifications that I know I have? And if you look at the plan you have and the specifications you have, the requirements you have, and they don't match, rethink your plan. Maybe the plan is right and the requirements are off. But in this case, the requirements are right and your plan may be off. So let's look at router 1. So we know it's an ABR, ASBR, backbone, and regular area router, all of these at the same time. So this is a fully functioning topology. This is the way it was at the end of my demo video for this lab. So let's look at the initial configuration before I do any of this. So step 1, basic configuration. Implement basic layer 3 connectivity. So I do IP address 192.168.1.1/24, 192.168.2.1/24, 192.168.12.1/23. And my network statements match. I've got a 255.255.255.0 here, and the network has an inverse mask of 0.0.0.255. So it matches. And it's in area 1, like it should be. It's a loopback stubbed as a /24. Like by the same token, 2.0/24. And here in the network, I see 2.0/24. Of course, it's an inverse mask, but it's the same mask. And then 12.0/30 with an 0.0.0.3 inverse mask, reverse mask, inverse mask, whatever you want to call it, wildcard mask. So all those terms mean the same thing. And of course, it's in the backbone, so it's in area 0. Now, what if I were to do precisely the same thing on router 2? What networks is router 2 in? Router 2 is in the 6.1 network, is in 6.0/24. It is in 12.0/30, and it is 23.0/30. So 12.0 will help me. This configuration from router 1 on router 2, that one matches. That's kind of a good way to think about this. If 2 routers have the same network statement, then, and they are actually in the same network with each other, they'll be able to talk with each other because they'll use that as a transit network. When you're thinking about what networks to advertise, think about what networks is it supporting in the access layer, and what networks is it using for internetworking in the distribution and core. So now think about this. Let's go a little farther on this. Let's look at router 3. Router 3 is in area 4.0/24, 5.0/24, 23.0/30. If I declare these 3 networks right here on /30, on router 3, do any of those networks exist on router 3? The answer is no. Now, we can also look at this inside the devices themselves. You see. Okay, so let's look at what we're going to do. So we've instead of once you've gotten into starting to implement this, if for whatever reason you don't have the plan in front of you, which is frankly a really bad way to build the network, you really need your subnetting table and your requirements clearly in mind as you're doing all of this, so that if something doesn't seem quite right, you can check. You can make sure it's right as you do it. So So what I'm going to do is show IP route, question mark. Okay, show IP route. Now, if I were to, because this is fully implemented, I would have to, actually, you know what I'm going to do? I have an idea. Let's imagine for a second that the static route is not there. So this line, ignore. And your inter-area route, ignore that too. So these are the connected areas. These are actually the lines you want to look for when you're thinking about what you advertise. So really and truly, if you wanted to do show IP route connected, you could do literally this, because these are the areas you care about. The C lines that have the network address /24. That is what you need to use to think as you're thinking about how to do this. Now you'll notice that when you do your interface configuration, like for example this IP address 192.168.1.1 space 255.255.255.0, what you do there, that's one configuration, and it actually shows up in your routing table on 2 lines. The address you're using is on the L line, the local route. The mask you provided is on the connected network line. So you're connected and versus local. So what you can really do show IP route pipe, do show IP route connected. And these networks, now, one thing we're not doing here, actually, we don't actually declare this network here. That's because what if that network changes? Do you really want to go in and change that? Now, granted, if it's in one place and it's it's a static, if it's a static, fully specified default route, you're going to have to go in and change it. But if it is a static exit interface route, it doesn't matter what's on the far side of that line. All you have to do is IP route quad 0 space the exit interface. So let me see, that's about 12 minutes. I'm going to stop this now. So pay really close attention to what you're doing. Think about which connected networks are on the device and then declare those. Don't ever declare networks that aren't on the device. And don't make the mistake of taking the network declaration from one device and moving it to another. Because the farther away you get from that device, the less likely that network block will be. So, thank you for watching.